It's not like that.
I just divided it.
So again, I'm going to
Two.
think of f of x in green, g of x in blue, and I quickly
I think they all kick my ass.
think of those graphs. I know the square root of x looks like this, and x minus 2, 1, 2,
It's like a trigger.
Positive slope.
Genius.
would look like that. Part A says, can we tell the domain and range of both of these, starting with the green one? X is bigger than or equal to 0, range. Y is bigger than or equal to 0. For the blue one, domain was everything. Range is everything. And it's nice to be able to quickly draw those graphs to see domain and range from that. Now we're going to divide. Okay. We're q of x, we want the explicit equation for q of x. So the explicit equation, we put f of x on top, which was the square root of x. We put g of x on the bottom, which is x minus 2. And we want to find the domain and range of this. Again, the domain is not too bad. And often on the exam, they'll ask you more domain questions than range questions. Because the range of this one is not pleasant to do, but the domain is not too bad. First of all, whenever you combine functions, so I'm combining the green and the blue together, the only way that you can combine them is if they both exist. So to start with, you see the green one is x is bigger than or equal to 0. So the domain for this one, we know that x has to also be greater than or equal to 0. But q of x also has a non-permissible value. You're not allowed to divide by 0, right? And when would you divide by 0? When x is equal to 2. So we have to add to the domain that x can also not equal 2. So the domain you could do just by looking at the equation, right? We're basically taking the two things that you know from math that you're not allowed to do. You're not allowed to divide by 0. You're not allowed to take the square root of a negative. So I know that my x values have to be positive or 0, but I also know that x can't equal 2. Now to figure out the range, we're going to draw this graph as best as we can. What do we know about this graph? Okay. First of all, we know that our blue graph is equal to 0 when x is 2. That's a non-permissible value. We know from chapter 2 that on a graph, non-permissible values are either holes or vertical asymptotes. In this case, because they both don't share the same, right? It's only a hole if it cancels out. And if it cancels out, you would have an x minus 2 on the top and an x minus 2 on the bottom in order for it to cancel out, which means on the top it would have been an x-intercept of the green graph as well. So from that information, we know that at the non-permissible value, we're going to get a vertical asymptote. Also from chapter 2, the degree of the top is a half because the square root is x to the half. The degree on the bottom is an x to the 1. The degree is bigger on the bottom. A degree bigger on the bottom, group 3, tells us we're going to have a horizontal asymptote at y equals 0. Question?
Your graphing stuff, when you're making your asymptotes, do you say like y can't equal 0? Or
When you
say
write
y
the,
equals
when you write the equation of the asymptote, it's the equation of the line. It has an equal sign.
So like
When we talk about non-permissible values and domains, we write can't equal. But this line's equation is x equals 2.
so what do you say X can equal to.
There's a half mark off.
It's
Just still, yeah. So when because it's the equation of an asymptote.
Uh-huh.
Anytime you have an equation of something,
That has to be.
it has an equal sign, because that's what an equation is. And if we're listing a non-permissible value, we're saying something it can't equal, then we put the line through. Yes. Yeah. Okay. All right. Now we only have to consider values bigger than 0 or equal to 0 to find our graph together. I'm going to draw the graph together in purple. Do you see that when you plug in 0, the green graph is 0? In fact, you can do like a lot of times with these graphs, if you have the equations, just plugging in values and figuring them out. If I plug in 0, I get 0 over -2, which is 0. Remember, points can be on horizontal asymptotes. What happens when I plug in 1? You see on this graph you'd have 1, 1. On this graph you have 1, -1. If you plug it into the graph here, you get square root of 1 over -1, which is -1. In fact, that's enough information to say it's going to go down towards the asymptote that way. What happens when you plug in? I'd probably plug in 4 next. And you see that 4 is nice. Square root of 4 is 2. 2 divided by 2, I'm going to get 4, 1. Square root of 3 over 1, I guess I could do that. Towards the asymptotes. Looks like this. This is what the graph looks like. What is the range of this graph? That's complicated. Look at it.
Everything.
It's everything. Even though it's broken up. Because this part above the x-axis has every single positive value that exists because it gets as close and close to 0 as possible without touching it. But it touches 0 here. Oh,
So difficult to understand.
right? So tempting with that horizontal asymptote, you'd be like, I got this, y can equals 0. Right? I can't do that snappy finger thing, but I can pretend I can.
This is very specific with like the arrowheads on the graph.
Yeah.
If the arrowheads go past the asymptote, is that okay? Or like how?
Like if you went like this, is that okay?
No,
No,
That's
okay.
an E21 error.
That's E10 error, actually, it's an E10.
like if your arrowheads.
Like this arrowhead's further to right than this arrowhead?
Yeah.
That's perfectly fine. Right.
That's just a dead taking. If they're taking marks for the stick marks for anything.
Oh, sorry, your first name has more than 5 letters. Yeah. Okay, so for question 2, circle 6, 13, and 16.